Hello friends, welcome to Pi study. Today we are going to discuss about friction force. So friction force is nothing but it is non-conservative force that is depend upon the path of surface. So this non-conservative force is energy loss, and this energy loss is converted to the frictional loss. So as we know, frictional force is electromagnetic in nature. So if we will talk about the path dependency of friction force, तो फ्रिक्शन फोर्स का जो पाथ पे या सरफेस पे डिपेंडेंसी है वो दो चीज़ों पे डिपेंड करती है, रफनेस एंड हार्डनेस. सो रफनेस, इफ रफनेस इज देयर, so sliding friction will develop. If the surface is hard, then rolling friction will develop. Now what is rolling friction? So before rolling friction, let us understand the compressibility and elasticity. Compressibility means it's a property of material so that body can be compressed up to a certain limit. एंड इलास्टिसिटी क्या होती है? जब किसी बॉडी पे हम कोई फोर्स लगाते हैं और फोर्स लगाने के बाद अगर वह बॉडी अपने पुनः शेप को प्राप्त कर ले, दैट मीन्स दिस इज द प्रॉपर्टी ऑफ इलास्टिसिटी. सो इलास्टिसिटी इज वन बाई कंप्रेसिबिलिटी. सो इन केस ऑफ रोलिंग फ्रिक्शन कंप्रेसिबिलिटी जीरो नहीं होना चाहिए एंड इलास्टिसिटी शुड नॉट बी इक्वल टू इन्फिनिटी. So if the surface is more hard, then less compressibility, and if less compressibility is there, then more elasticity and less rolling friction. So for less rolling friction, more elasticity should be there. Now there is one wheel and there is one undulation on the road. So when the wheel is moving on this road, so when the wheel is coming from this to this place and it is go down in this part of the road, then when you apply the force F in this direction, then the force required to break the interlocking at this point, because the interlocking will be at this point, because at this point this is the corner. So at this point also it is the some kind of normal force developed. So the maximum interlocking will be at this point. So the friction is nothing but the required force to break the interlock. अब इसको हम समझते हैं कि इक्विलिब्रियम इक्वेशन के माध्यम से. सो फॉर दिस सिस्टम द टाउ नेट इज इक्वल टू 0. नाउ द फोर्स F, we are applying force F in this direction. So normal force will develop at this point of contact, and mg is in downward direction. So if the radius of wheel is r, then you can write the equilibrium equation F or cos theta minus mg sin theta is equal to 0. Then rolling friction is nothing but mg tan theta. अब रोलिंग फ्रिक्शन का जो प्रैक्टिकल यूज है आपने देखा होगा, अगर किसी सड़क पे कोई गड्ढे हैं, if there are some kind of undulation on the road, so the shape of undulation depends on how much friction required to come over that undulation. अब यहाँ पे अगर एंगल θ1 है तो the friction force required to break this interlocking is F1 is equal to mg tan θ1. If angle θ2 is greater than θ1, then F2 is equal to mg tan θ2. If this angle θ2 is going to 90 degree, that means when your wheel is completely inside half of its radius on the undulation, then the friction force, then the force required to break interlocking is infinity. तो आपने देखा होगा इस केस में जब सड़क पे जो अंड्यूलेशन है, सड़क पे जो अंड्यूलेशन में जब व्हील आधा इन चला जाता है अंड्यूलेशन में, then you have to make the infinite force. That means you never can get over the wheel applying the force in this direction. Then what you need to do, you need to apply the force in this direction, you need to force in this direction, or you will directly try to uplift the wheel. So this is the practical use of friction force. Now the second thing is sliding force. Sliding force depends upon the roughness of surface. If the surface is smooth, then you can neglect this kind of sliding friction. But if the surface is very high, very smooth, then very high friction will develop, and this very smooth surface require force to break the mutual bond. And how the mutual bond will be there? This is due to the overlapping of electric field between the contact. Now roughness of surface. This roughness of surface has been studied in two parts: static friction and kinetic friction. In static friction, no relative motion between the two surfaces in contact, and always oppose the cause of motion. But in kinetic friction, there will be relative motion between the surface in contact, and this kinetic friction try to minimize the relative motion between the two surfaces in contact. Now friction force. What is friction force, and what is we have seen the friction force, like it is a required force to break the interlocking. But there is somehow some effect of temperature on the friction force, and these two, static and kinetic friction, are comparatively quite complex. So let us understand what are the complexity in this. So if you have two block and you are pulling with the force F, so there will be some mutual interlocking, some disturbance will be there at the interface between these two blocks. So some people say this is the friction force. Some people say when we will pull this one, then there will be generation of temperature, heat generation. And in some other explanation, this concept is explained in this way, like at different point of contact there will be some friction force, there will be friction in terms of that is required force to break the molecular bond. Now molecular bond at high pressure, because at this point this block is resting on this block and there is some contact point, so this block will break, this bond will break at high pressure. So after breaking molecular bond, molecule start vibrating. When the molecular at this place and this place start vibrating, then temperature of body increased due to the surrounding temperature, and energy of body flow from body to surround. So what does it mean? It is loss in energy, and this loss in energy converted to the friction loss. So if you understand about the static friction, if any block is rest, then there will be two kind of friction force develop. F is equal to F1 plus F2. So F1 is required force to change its state from rest to motion, and F2 is required force to break interlock. If this block is in motion, then this F1 will be going to 0 because there will be no interlocking, only F2 will be there, required force to break interlocking. So in this case, this is the static friction, this is the kinetic friction. So from this and this comparison, you can say that static friction is greater than kinetic friction. So what is the actual friction when the body is in motion? When the body is in motion, then the actual friction is nothing but the kinetic friction. Now there are three experimental ideas about the comparison of friction force for just slip. These blocks are resting, and in this case the acceleration is upward direction. There is in this case no acceleration, in this case acceleration is downward direction. So when you apply the force, then there will be normal will be there, normal component of this block is there, so the gravity is upward direction. So when you apply F1, F2 and F3 at all three blocks, then F1 is greater than F2 is greater than F3, and in a similar way N1 is greater than N2 is greater than N3. So how this F and N relate to the friction force? So friction force is nothing but this F proportional to N, and in this way, if you are applying the force, then there will be coefficient of friction. That is another property of friction force. So F proportional to mu. So when you combine this equation F proportional to mu and F proportional to N, then you will get F is equal to mu N, where mu is the coefficient of friction. Now a block of mass m is resting at this place. Find out the contact force. So the normal force will develop, the friction force is developed, F is equal to mu N. So F net is equal to resultant of this and this is equal to root over N square plus F square, N square root over mu square plus N square mu square. So mg root over 1 plus mu square. So mg is less than equal to F net is less than equal to root over 1 plus mu square. So you can calculate the semi-cone angle or friction angle using this concept. So normal force is there, friction force is there. So this angle is the semi-cone angle or friction angle. So tan theta is equal to, from this geometry, F by N, theta is equal to tan inverse mu. So if it will be asked what is the locus of net contact force, so that is nothing but the cone. Now in next module we will learn about the angle of repose in friction force, and we will also discuss about some numerical examples related to the how the friction force is affecting our life in a real manner. Thank you very much.